Hi, my name is Allison Chang, and today I'll be introducing an analysis of the tiny home trend and how it increases awareness of sustainability while incorporating concepts of computation covered in this class. The tiny homes movement is a recent social and architectural trend advocating for living simply as well as living in homes that are, by definition, under 400 square feet. These homes also promote financial prudence and sustainable living and pose an interesting problem, again, to optimize space with a multitude of conflicting restraints. This poses the question, why should we forego our traditional homes for these new tiny homes? And this trend was largely a reaction to the increasing materialistic nature of homes, with the rising popularity of massive homes, especially noted by the McMansions trend, which those houses typically range 3,000 square feet. And it is clear that buildings count for 38.9% of total US energy consumption, and that is 50-50 between residential and commercial buildings. And in terms of electricity consumptions, buildings also account for 72% of the total US population. And just from 1983 to 2013, we're seeing a massive 50% increase in the square footage of the average home, and we're just seeing immense wastage from water consumption, electricity consumption, and land use. There is a stark contrast between the ecological footprint of tiny homes, where it can operate on 914 kilowatts a year, producing 1,200 pounds of carbon dioxide on average, whereas the average traditional home requires 12,733 kilowatts and produces around 16,000 pounds of carbon dioxide. And on top of that, tiny homes take at a maximum of 400 square footage, where, as you see, that the modern trend is upwards of 3,000 square feet. And tiny homes can also achieve water savings of 20%, including the water heating and the water itself, so we're seeing an immense decrease in the amount of consumption. Since the process of creating a tiny home is extremely consumer oriented, I have found that the interaction between builder and customer sets up well for the branch and bound algorithm, because it is able to work out every constraint as well as extending the network until the optimal solution is found. I identified the objective function as maximizing utility, since the primary role of the builder is to maximize the customer's use of space and meet as many demands as possible. Next, I separated the components that compose the objective function, and where the maximum is derived from the amount of utility from a bedroom, living room, bathroom, kitchen, and storage to cover the basic needs. And based off that amount of utility, the constraints are identified as budget, total square footage available, the voltage maximum, and water storage/usage. Once the list of demands and constraints are comprehensive, then the builder can run the functions through a computer solver like Excel and be able to streamline the process to find the best fit build for a tiny home. The tiny home trend is mostly classified as a mobile home, and it is not conducive to every single family's living style. And however, it still is able to discourage materialistic desires, integrate sustainable living, and introduce a newfound emphasis on consequences rather than satisfaction. Thank you.